Okay guys, in this section of the course we are going to talk about blocks. First we are going to start pretty simple and I'm going to show you how to make your own blocks, how to insert the same blocks and make small modifications. In this lecture you will get the basic idea behind blocks and see why they are so commonly used. After that we are going to continue and I'm going to show you how to make your own reusable block library, how to access it and use the blocks inside it. Then I'm going to continue and talk about external resources. In this lecture I'm going to show you how to find pre-made block libraries, how to use them and make your work more efficient. So, see you in the lectures. Okay guys, in this lecture we are going to talk about blocks. Firstly I'm going to go through the main idea behind blocks and show you why they are so useful. Then I'm going to show you how to create a block, insert a block and modify a block. I have this drawing here just to show you an example of how really blocks look like. If I zoom in and hover over the bed, you can see the bed is a predefined block. Also, the chairs are predefined blocks. And we can notice the blocks from their complexity. You can see we have complex drawings that are inserted in our drawing over and over again in different positions but with the same characteristics. And basically that's the power behind blocks. You create a drawing, define it as a block and store it in your block directory, so you can use that drawing whenever you want and wherever you want. It depends on your needs. This can be pretty powerful and it will save you a lot of time. One additional feature behind blocks is that you can make modifications to the block and the modifications will be applied to all the previously inserted blocks. For example, if I make a modification to one of the chair elements, chair blocks, the modification will be applied to all the chair blocks in this drawing. So you can see the power of it. Now let me go ahead and show you how to create, insert and modify your own blocks just to get the hang of it, and for that I prepared something, so let me go ahead and show you. In here we have this predefined drawing. As you can see, it's kind of complex. It contains these chair blocks that are actually predefined. We have also the table element here, so we are going to create our own block while using this complex drawing with predefined blocks and additional objects. So when we deal with blocks, we usually use this section here. Firstly, the insert option. As you can see, it allows us to insert a predefined blocks. When we create our own block, we will have additional options here. If we want to create our own block, we will use these two here, create to, and it will allow us to specify the properties of our block. So let's see what we have here. First we have the name section, so in here we have to define the name of our block. I will call it as table. Then is this base point section. In here we have to specify the base point of insertion. We can use these two, pick point and specify the insertion point on our screen. If I select it, I'm allowed to select the insertion point. Additionally, we can specify the point through the coordinates. The next section is this object section. In here we have to specify all the objects that will contain the block. We can use these two here and select the objects that will define the block. Additionally, we have this retain, convert to block and delete option. The first one, the retain option, it will retain the object as they currently are. The block will be created, but the current drawing will be retained. The convert to block option, it will convert the current drawing into a block and additionally create the block, and I will leave it as convert to block. If I select the delete option, the current drawing will be deleted, but the block will be actually created. In the behavior section we have the scale uniformly option, so it will allow us to uniformly scale our block. I will leave it as OK. We have allow exploding option, and I'm going to allow it and show you how to explode it later on. So I'm going to leave this, and we can add additionally annotated feature that I will leave them as blank and talk about that in a later section. And in this settings section we can specify the block units. You can see we have lots of options. Let's say for example specify it as centimeters, and the last section is the description section. So in here we can add a description and specify how to use the blocks and actually what they represent. So I will leave this blank and click OK. And let's see what we have. If I hover over our previous drawing, you can see that the drawing is converted into a block. We previously specified that option. If I choose retain, the drawing would be retained as it was before. Let's go and insert our newly created block. As you can see, under the insert option we have our newly defined block. You can notice the insertion point that we previously specified, and actually between these two drawings there are no differences at all. They are identically the same, and you get the idea. You create the block, insert it in all of your drawings. Let me now go to this block editor tool and show you how to make a modification and see what will actually happen if we modify one of the blocks, and see how the changes apply. If I click on the block editor, you can see I have to specify firstly the block that I want to modify. I will select the table block, and this new menu will appear. As you can see, we have lots of options here. I'm not going to go through all of them in this section. I will talk about them in a later section. Now I'm going to make a small modification just to show you how things actually work, and for that I'm going to draw some axes on the chairs. Let's copy the same axes and apply to some additional chairs just to make a bigger modification. Let's use the mirror option and apply the same changes into the chairs below. And if we want to apply the changes, we just click on this close block editor tool. If I click on it, I have to click on this save the changes, and as you can see the changes are actually applied, and you can notice the power behind of it. You can see that when I make a modification, if I try to insert a new block, the modifications are applied to our newly inserted block. So you can see that dealing with blocks is kind of easy. It's easy to create your own block, it's easy to modify them and adapt them to your drawings. They can come quite in handy, they are quite practical and will save you a lot of time. So if you know how to properly deal with them, you will use them quite a lot. So now let me show you how to explode the block, and let's say bring it back to the objects that previously defined the block. As you saw before, when we created the block, we allowed the exploding option. So if I type explode and use it on this block here, it will explode the block into the objects that previously defined the block. You can notice that now we have a separate chair block, the table. Also, you can see all the chair blocks. You can notice the lines here, and this can come quite in handy when you want to modify one block and not apply the same changes in all of the blocks. We can go even further. If we want, we can explode the chair block and let's say make our drawing even more simple. And that's one additional possibility how to modify your blocks, and basically that covers the main idea behind this lecture. So see you guys in the next lecture. Okay guys, in this lecture I'm going to talk about saving and making reusable libraries of blocks. So we have this drawing here and I'm going to show you how to save this file and later reference to the blocks inside the file. I will talk about common practices, where and how to save your drawings, so you will have, let's say, a better understanding of how to use them. And as you can see in this drawing, I have some randomly created blocks. If I hover over everything, you will see that they have the same characteristics. And basically, when we want to create a block library, we usually save the drawing that contains the blocks, and we usually save them as an ordinary CAD drawing. By default, it opens this directory here. Basically, this is my folder for saving blocks, so I always reference to it if I want to use my drawings that contain my blocks. A common practice is to save your drawings in a predefined folder. Usually Autocad gives you a default folder, but I store them in this Autodesk blocks folder. And you can see here I have all the drawings that contain my blocks. I will go through them later. Now I want to save my newly defined block. I will call it new blocks just to see how we can insert those blocks later on. So as you can see, my file is saved and I'm going to create a new drawing. If I go to the insert option, click on it, and you can see we don't have any blocks yet. So we have to reference to our previous drawings so we can find the blocks. I can use these two here, blocks from libraries. If I click on it, this menu here will appear. In the libraries section, let's say I previously inserted some libraries, and you can see here we can find all the blocks from that library. And here you can see the library name. Basically, it's an Autocad drawing. It's called Bar Design 3D and it's saved in a DWG format. So if I want to reference to my previously created blocks, I have to find, if I click on here, I have to find previously saved drawings. By default, my Autocad refers to this blocks section. You have to find the folder you specified your blocks in. I use this block folder as I told you before, so here I have all my drawings with the blocks. If I click on something on the right, you can see I can preview the blocks defined in those drawings, so I know where I reference to. Our drawing was this new block drawing. If I open it, it will take some time to load the drawing, and here it is. Now you can see we have all the blocks of our previous drawing, and if I want to insert one, I just click on it and I have the option to insert the block. Let me show you another one, and you can see the beauty of it, and just imagine how much time you can save if you have, let's say, projects that have repetitive drawings in them. You can define a block section, block library, and use that library in all of your projects. I just want to show you the home menu here behind blocks. If I go to the recent option here, these are my recently used blocks. In your section you will have the blocks you recently insert, and under the current drawing section we have all the blocks in this drawing. So if I click on something, you can see we have the same block as in our drawing. If I go to the insert options, we can, let's say, scale the block directly, even rotate it. We can use this repeat placement option and even explode the block before we insert it, so the block will be inserted as the objects that define the block. I won't go through all of these options. You can go ahead, try them, experiment, and see if these options fit your needs. I want to show you one additional way where you can store your blocks, and you can find that tool here in the view section. If I go there, and this is our tool, the tool palettes. So here we have different tools that we can reference to. As you can see in the architectural, mechanical, additionally in the electrical, civil and structural section we can find predefined blocks. We can use these predefined blocks as much as we want. You can try them out, they can be pretty useful. As you can see in our drawing, I actually use some of these blocks, and if you are familiar with this tool, this can be pretty practical to use and make your drawings more efficient. I'm going to show you how to create your own section. So you can store blocks and, let's say, tools to use them whenever you want. We just right click on here, select new palette, let's say call it new blocks, and as you can see we have our own section. If I want to add a new block, I just go to the block that I want, drag the block and drop it in our section. We can add multiple blocks and even we can make modifications. If I right click on some of the blocks, you can see there are possibilities to edit the block. I will rename it and call it as EP. So you can see we can specify this section, modify it and add blocks according to our needs. This can be quite a helpful tool if we know how to use it, so I think you'll get the idea. And in the next lecture I'm going to show you how to find different sources to add predefined blocks. Okay guys, in this lecture I'm going to show you how to use external sources and find predefined AutoCAD drawings that contain AutoCAD blocks. And basically you find these sources on the internet. Actually now I'm on the Autodesk official site, and as you can see the site recommends some forums or sites that you can use to download predefined AutoCAD drawings and refer to their blogs. You can find almost everything here, but before I talk to that, I wanted to show you this design center folder. And actually this folder comes automatically, so when you download AutoCAD, you will have this folder in your Autodesk directory. So this folder will actually contain some predefined drawings that are based on blocks. So you can use these drawings and refer to the defined blocks in there. You can find some pretty useful stuff in here. Personally, I don't use them as much, but maybe in your case this can be quite helpful, so please check them out. Now I will continue with the recommended sites and forums. So you can see that we can find predefined block libraries on the internet. I'm not going to go through all of them. Please check them out if you are interested. I'm going to recommend this Cut Blocks free AutoCAD file site. And you can see this is quite a rich site. You can find almost everything here. You have vegetation blocks, bathroom blocks. If I scroll down, you can find blocks for doors, for staircases, and so on and so on. Please try them and find the blocks that best suit you. We can even go to Google and type download AutoCAD blocks, and some sites will come up here. You can check them out. I usually find my blocks like this. My preferred site is this simple site. If I go there, you can see a variety of blocks. Most of them are free, but some come with a price. I usually download the ones that are free because basically almost always they match my needs. You can see you can find everything here. Now let's find something to download and use in our drawing. I think this old fire truck is a cool block. Let's open it and just click on download, and as you can see we have a DWG file that's downloaded. On the left side here you can even search the blocks by the type of the block. You can see we can find here bridges, architectural details, graph symbols, and so on and so on. So let me go to the download section, cut the file we downloaded, and move it to the blocks section. That's the folder you defined for storing the blocks. Now let me refer to that drawing and use the blocks inside of it. I open the drawing, and as you can see the block appeared here. I can click on the block, don't redefine, and just insert the block. And as you can see we have the block that we downloaded from the internet. You can find almost anything on the internet. I usually get my blocks from the internet, so I encourage you to go try and search to find the blocks that best suit your needs and make your drawings more efficient. And we will see each other in the next section of the course. We are going to talk about attributed blocks. Firstly, I'm going to show you some common examples just to get the idea behind attributed blocks and know where to use them. Then we are going to continue and create our own attributed blocks. After that, I'm going to show you how to manage the attributed blocks, make modifications, and adapt the attributes to the required needs. And in the end, I'm going to show you how to extract the attributed data from the blocks. We are going to extract the data into a table in the drawing and into an external Excel file. So, see you guys in the lectures. Okay guys, in this lecture I'm going to talk about attributes. I'm going to start with some common use cases. Then I'm going to continue and show you how to create your own attributed blocks. But first, let me explain what attributes actually are. Basically, attributes are taglines that are attached to a defined block. So the taglines will dynamically or statically input data to the block. For example, I have this drawing here. We have the block, and let's say this block represents elevation of a house. The second one represents some specification of, let's say, an element of the house. And actually the attributes are the text inputs. So when we assign this block, automatically we define an attribute that will prompt us to add a text for the block. Additionally, there is a possibility to have a repeatable drawing of an equipment, and we want to use the same equipment multiple times in our drawing, but the equipment, let's say, has variable characteristics, like for example a different producer every time, different parameters in some way. So if we want to define that, we can use attributes to change the block properties, so the text will be displayed different in every situation. And in our last drawing, let's say we need to define the speed limit on a highway, so we can define a block of a sign and manipulate with the text while using attributes. So whenever we insert the block, the attribute will prompt us to define the actual speed limit. These were some common examples just to give you an idea what attributes really are. Now we are going to create our own attributed blocks and see how the whole process goes. I'm going to copy this last drawing here and bring it here. As you can see, I've drawn the lines outside the block, so I'm deleting the block, and to make things similar, I will use the hedge function. And now, as you can see, I have the whole structure. I additionally need to define the attribute. For that, I'm going to use the block section, and under there is a tool called define attributes. The same tool we can find in the insert section, and here it is, define attributes. And if I click on it, this menu here will appear. Under the attribute section, we first need to define the tag. So our tag will be max speed, the prompt value, so I will call it as define maximum speed. And in the default section, we can select these two, and there are some common use cases that we can choose from, but I will talk about that later. Now I'm going to show you, as a default value, we can add a value that will always appear, but a common practice is if I want to add numeric inputs, I will specify, let's say, some placeholders that will remind me of a numeric input, and I commonly assign these two signs when I want my attribute to be numeric. When I want my attribute to be as a text, I usually assign different value, something like this. So when I see this value, I will know that I need to specify a text input. So now we need a numeric input, and I will assign this sign here. In the text section, we can specify the text. So the first option is justification. I will set it to middle. Then we can specify the text style. So if we have a text style, we can choose from it. Additionally, there are annotative features that we can add. We can specify the text height. I think for our drawing, the text height should be 2.5, and even we can assign a rotation. And under the mode section, as you can see, we have multiple options that we can choose from. The lock position is defaultly assigned. The first one is the invisible option, so the attribute will be invisible. The constant, so it will add a constant value to the attribute. The verify option, it will prompt us to verify the attribute before we insert the block. The preset option, so there is a possibility to preset the attribute. Again, the lock position, I will leave that to be applied, and the multiple lines option, so there is a possibility to allow the attribute to have multiple lines. And the next section is the insertion point, so automatically specifying on screen is assigned, so I will leave that, and we are good to go. I will click OK, and as you can see, I have to insert the attribute, and now we need to create a block. I will go to the create block tool. I will call my block as speed sign. Firstly, we need to specify the pick point. I will specify the middle. I will specify to delete the objects when we create the block and specify all the objects. The other tools I will leave as default, and as you can see, my block is deleted, and here we have the same block. So this is our block, speed sign, and as you can see, the placeholders are here, so I know I have to input a numeric input. And this is where we define the input, so 60 is enough, and this is our attribute. We can insert the block once again with a different value inside, so if I insert it, it will ask me for a number. I will specify the speed limit as 90, click OK, and as you can see, we have another block here. And basically, I think you get the idea. If you get the hang of attributes, you can use them very often in your drawings. Now I want to show you a different use case. So whenever you want to create a standard block table for your sheets, and in the title section, we can use attributes to define the text in the sections. So let me go ahead. First is the project section, project fields, so under tag name, I will select project, the prompt will be define project, and as a default value, I will specify a placeholder for text input. I will justify it in the middle and select a text height of 2. OK, and let me input the attribute. The next field is the title field. I will add as a tag title in the prompt, define title, and a default placeholder. I will justify it to the middle and OK. And actually these are the two fields I wanted to talk about. Define the attribute. The tag will be drawing. The prompt will be define drawing. And in the default section, I will use the default to insert the fields. So as you can see here, we have lots of options. I won't go through all of them, but just to show you the main idea. We can specify author, block placeholders, comments, create a date, and so on. Let me scroll down. As you can see here, we can specify the date, the device name. We can even specify hyperlinks formula, but I will specify the file name. And as you can see, our current file name is drawing9. And by default, the attribute will be the same as the name of our drawing in the required field that we define the attribute. Like in the format section, I can choose make it as upper, lowercase. I can even display the file extension, but I will leave it as blank. And this is enough for our field, so click OK. The other options I will justify to middle, and we are good to go. And let me move it a little bit higher. Okay, now the date field, define the attribute, the tag will be date, the prompt will be define date, and I will specify a default value here, the date field. And as you can see here, we have lots of formats for the date, but I will specify the default one. It's a pretty good format for me. Click OK and just justify to middle, and we are good to go. Okay, let me move it a bit higher also. Now we have to create the block. Let me create the block. I will call it as standard sheet. Specify the pick point, and I will select the retain option and select all the objects. The rest will be left as default. Click OK and let me insert a block. And now I have to specify the fields. You can see the date field is the current date, and in the drawing field we have the file name. If I change the file name, automatically the field will be updated. In the title field I have the placeholder, so let us define the title. I will call it as house position 1, and the project will be our new house. Okay. If I zoom in, you can see all the fields. In the drawing and the date section, you can see that the drawing name is the current drawing name and the date is the current date. You can notice that these two fields have a color background. So basically this is to remind us that the text here is dynamically inputted and this won't be plotted when you plot your drawing. And basically that's it. So you have a good idea how attributes are used, and that's enough for this lecture. See you in the next lecture. Okay guys, in this lecture I'm going to show you how to deal with attributes, how to modify them and visually inspect them. And for that I've inserted this drawing here, and if I zoom in you can see that all the text input actually is attributed text defined into a block. And if I want to deal with attributes, I will go in this section here, and the modified tool is this, so I'm able to select a single attribute, and let me select one just to see. If I click on this attribute, this menu here will appear, and here I have options to, as you can see, I have information about the attribute, the tag, the prompt and the value. If I go to this tool to select the block, it will display different information for the other attribute. As you can see, the values of the other attribute. If I go to text options, I can specify the text style. Let's say change it to standard, but things can get messy, so let me return it. I want the Romance text style. You can justify the text. Let me select middle, select the height, even specify a rotation angle, the width factor. We can select an oblique angle, we can add annotated features, even we can make the text upside down. I won't do it, but it's possible. And under properties, we can change the layer, the line type, the color. Let me change the color. Let me make this attribute as blue. We can change the line weight and so on, and as you can see the changes are applied. So that's one possibility to deal with attributes. Another option is also in the blocks section, and this is the attribute manager. If I click on it, this menu here will appear, and here we can find information about the attributes. Additionally, under this block section, we can select the block, and let's say selecting the block chair, and under the chair block we have all the attributes defined under that block. You can see the tag, the prompt, the default, the modes, and annotated features. Additionally, if I go to this tool, select block, it allows me to select the block, and automatically it goes to the block we've selected. And if I click 2 times on the attribute, this menu here will appear, and here I have possibilities to make additional changes. Some of the menus here are exactly the same as the previous one. Additionally, I have this mode section here, so I'm able to, let's say, apply other options of the mode section, and these data sections, or I am able to change the tag name, the prompt, and the default value. Basically, this can be pretty useful if things get messy for you. This is a common way to deal with attributes. Okay, I won't make any changes, I will close this, and I want to show you another option. That's the synchronized attribute option. So if we want to make any changes to the block, let's say using the block editor, let me try it. I have to select our block, and let's say I want to scale this text. Let me scale it to say 2, and this thing won't match, but it's just for a demonstration. I close the editor now, I will apply the changes, and as you can see, nothing happened here. But if I try to insert our block, you can see the modifications are made. And as you see, I have to specify the text. It will be the same text. Let's say OK. And you can see the text is quite bigger than the ones we have in our drawing. So if I want to apply the changes, I will use this synchronize attribute tool. If I click on it, firstly I have to select an option. I can even type the name. I prefer the select option. So let's say select a block and click on yes, and as you see, the changes are applied to all the attributes. So this is one tool. If you make any changes, another option is this display option. So if I click on this, I have options to hide all attributes. Let me click on it, and you can see all of the attributes are hidden. And I can turn them back, let's say display all attributes, and retain attribute display. Basically, the main difference between the retain attribute display and the display option are, let me show you. This is because we can select an option in the mode section, these invisibility options. So if we have invisible attributes, they won't be shown with the retain option, but they will be shown with the display all option. And actually that's it about this lecture. Now you know how to modify your attributes, and let's see what we have in the next lecture. Okay guys, in this lecture we are going to talk about data extraction, and I'm going to go through the whole process and explain why and how data extraction is done. For this example, I'm going to show you how to extract the data of our attributed blocks, but actually the whole process can be applied for different information about our drawing. And we are going to extract the data into a table inside of our drawing and into an external Excel file. So let me begin and go to this Annotate section, and the tool we are going to use is this extract data tool. If I click on it, as an option I have to create a new data extraction, and there is another option to edit an existing data extraction. In this case, we are going to use the first option to create our own data extraction, and this is the data where we are going to extract. We need to specify the data source. By default is the data from our current drawing. We can select objects in the current drawing, and for that we can use this tool here. So it will allow us to select all the objects we need in our drawing. If I click on it, I have to select all the objects, and the data will be extracted from the selected objects. I actually won't use this. I will select the whole data of our drawing. Additionally, we can add a whole folder, and the data will be extracted from the folder. We can select options like automatically to include new drawings that are in that folder. We can include subfolders and even specify a wildcard character, so it will know what type of files to get the data from. By default is the DWG, but we actually won't use it. And we can add additional drawings, so this tool allows us to select the drawing and it will be added in our data extraction files here. Okay, we are going to use just this drawing. I will select next, and in this section we have to select the objects for data extraction. As you can see here, we have all the objects in our drawing. In this case we don't need them all. I will select this and display. I will select just the display blocks only section. So I will extract the data only from the box, and additionally I will select this to extract the data only from the attributed blocks. So now we have these 5 objects and they are enough. If I go next, in this section here we have to select the properties of the data that we want to extract. As you can see, we have lots of options here that may or may not match your needs. So go ahead, scroll this out once and check what options you have. And on the right here we have a category filter that you can select the required properties. I will uncheck them all and leave just the attribute property, and as you can see, our attributed data. I will go to next, and in this section we have to refine the data, and here we have the table. So this is the table that will be outputted. As you can see, the room number attribute with a unique number and a count of 1, and also the attribute for a computer and a chair that have a bigger count. We can modify the data. Let's say uncheck this combine identical rows, and you can see the changes applied to the data. We can even show count columns, as you can see, show name columns, and we can even link external data. So there is a possibility to link an external data source to this. I won't show you this, you can experiment by your own. And there is a sort option, so we can sort columns in ascending, descending order. Even we can select the columns that we want to display, and I won't mess with this. I'll click OK, and here is a full preview option. So this will be all of the data we will extract. Let me go to next, and here we can choose the output. So there is an option to extract the data into a table in our drawing. So I will check this, and there is a possibility to extract the data into an Excel file, CSV file, MDB file, and a text file. I will select this also, and as you can see, the data will be extracted as an Excel file. Let me just change the directory in a folder that I will easily find. So this is a good folder, save it, and next. In here we can specify the table style. If we have some styles for the table, we can choose them. We can make our new table style. Even we can format the structure. Let me edit the title and call it as attribute data. We can even change the tail style, so you can try these things on. I won't mess with them. And we can use property names as additional column headers. That will be checked. So let me go next and let's insert the data. Okay, let's scale it just so we can see it better. I think it's enough, and as you can see, the attribute data table with all the columns. We have the room number with a unique number and a count of 1, and also the computer and chair attributes with bigger counts. So this is the data inside of our drawing. Let me show you the data into the Excel file. Okay, this is our Excel file. Let me open it, and as you can see, here we have the same tables. There is a possibility to make a link between the drawing and this external file and change the data into the drawing by changing the data into the Excel file. So you see how easy it is and how much of data size can be outputted in a really short time. So this can be pretty powerful, and go ahead, try, experiment, and use them as best as possible. And that's it for this lecture. See you in the next one. Okay guys, in this section of the course we are going to talk about parametric drawings. I'm going to guide you and show you all the options that parametric drawings can offer. Firstly, we are going to cover the possibilities of geometric constraints, then we are going to continue and talk about the power behind dimensional constraints and all the possibilities of their use cases. So, see you guys in the lectures. Okay guys, in this section we are going to talk about parametric drawings and constraints. So I'm going to cover the basic idea behind parametric drawings and guide you with all the steps on how to use constraints, how to manage them, and how to assign them to your drawings. So basically when we deal with constraints, we are in this parametric section here. So we have two types of constraints: geometric constraints that I will cover in this lecture, and dimensional constraints that I will cover in the next lecture. And basically these are the options for geometric constraints. We are going to use this drawing here and assign all of the constraints. Firstly, we are going to start with this auto constraint option, and let me show you. If I use this and apply it to our drawing, automatically in the drawing will be assigned with constraints. We are not familiar with the signs yet, but I will cover them next. This was just a demonstration of the auto constraint tool, and this tool is quite powerful, and we will use it in the dynamic blocks section. So let me go back and cover all the constraints one by one, just to show you what actually is possible. Let me show you. So the coincident is the first type of constraint. I can apply it to two lines that are connected to each other in a dot, and as you can see, this blue dot was generated. So now the lines are connected to each other. If I try to rotate one of the lines, the other one will follow. Let me show you. If I move it, you can see the other one will follow. The same thing applies to the other one. If I try to rotate the other one, the first one also will follow it. So these two lines are connected to each other no matter what. Let me go back and assign the same option to the other ones, just to show you how the whole drawing will behave. Okay, this is the last one, and if I try to rotate this line, you can see the other ones follow, and basically this is the idea behind parametric drawings. So we have a drawing that actually works together. Let me go back. The next tool is this parallel tool, so I can make two lines to be parallel to each other. Let me select it and assign it to these two lines, and if I try to rotate one of the lines, you can see the whole drawing was modified and the two lines are parallel to each other. Okay, let me go back. The next tool is this tangent tool. I can assign it to the circle and one of the lines. So this will be the line, and as you can see, the line is a tangent of the circle. So this is the tangent option. The next option is the collinear option. So for that I actually have to make one additional line to be applied. So let me do the line, and like this, go back, and if I select it, let's choose this line, and as you can see, the two lines are collinear to each other, and if I make any changes, the other one will follow. Let me go back. The perpendicular option, so I can make two lines to be perpendicular to each other and have an angle of 90 degrees. So let me select it to these two lines, and if I make any changes, you can see the whole drawing is modified and the two lines stay perpendicular to each other. Let me try make some other modifications just to see, and you can see the angle here stays the same. Okay, the next section, the next tool, I will show this horizontal constraint. So now the whole the line has a horizontal constraint, so it's not able to move in the vertical direction. And the same applies with a vertical constraint, so let me apply it. And actually my drawing has too many constraints, so I'm not able to apply it, but I think you'll get the idea. This smooth option, for this option I have to make additional lines just to show you. I won't make a polyline, an arc, not an arc, let me make a spline. Okay, this is the spline, and apply it, and let's make one additional line. Okay, this is the second line, and let me show you what will happen. I will apply to the first line and the second one, and now we have one smooth line that's actually defined by the two previous line. If I try to use the same option with the lines and the circle, actually it won't let me, it will tell me that this is an invalid function. Okay, let's see the other tools, the symmetric options. Let me make another circle just to demonstrate. So I will make the two circles symmetric to each other. Select the second object, the second circle, and the symmetry line will be this. And as you can see, the circles are actually identical to each other. If I make any changes to one of the circles, the other one will follow. The equal tool, I can make two lines to be equal to each other no matter what, and as you can see, if I make changes, the other one will follow. Okay, let me go back, and actually now we are not able to move this object. We can make this line just bigger and move it in the horizontal direction. and you can see the whole drawing behaves like a parametric drawing. So this is the last option, the fix option, so I can make one object to be fixed, so I'm not able to move it in any direction. As you can see, these two circles are symmetric, so I'm not able to move them. Let me assign it to this one, and now you can see that I'm not able to move it. Okay, so this is the fix option, and actually that option makes a line or a dot fix relatively to the coordinate system. And actually with that we covered all of the geometry constraints. In this section here we can manipulate with the view. As you can see, I hide all the constraints, and if I click on one of the lines you can see that the constraints will appear. I can additionally click on multiple lines, and that's it. If I select show all of the constraints will be shown, and I can even select manually what constraints to show, what constraints to hide. And actually, if things get messy with your constraints, you can use these options to make your drawing, let's say, more tidy. Okay, I will leave them as all to be shown, and I want to show you one additional thing. That's it, this infer constraints option, and if you don't have it here you can find it in the customization section. If I click on it, this is the option, and just select it, and now if I try to draw something, you can see that automatically constraints were generated, and basically the type of the constraints mostly depends on the way I draw my drawings. So I use the ortho mode, and you can see that horizontal constraints were made on some of the lines, and actually with this option the constraint will be assigned quite strictly. You can see I have constraints on all the lines, even on the dots between the lines, so the moving capability of the drawing is limited. Okay, I think that's it about geometric constraints. Uh, I hope you get the idea, and in the next lecture I'm going to talk about dimensional constraints, so see you then. Okay guys, so in this section I'm going to talk about dimensional constraints and show you what are the benefits of using this type of constraints. So all of the tools are in this section here, named as dimensional constraints, and I'm going to start with this, the linear constraint, and show you what's the idea behind this type of constraints. So let me try and select it. Second constraint, you have to be careful when assigning this. You can see there is a red dot. A red dot is appearing when I try to assign it. You can, by accident, I can assign it to the middle. I don't want that. So let me click on this, and this is my dimensional constraint. So if I try to change this dimension here, let's say to 100, and the line will fall. So I think you get the idea. Basically, we define a constraint, and actually the lines of the drawing will always follow the constraint. It's pretty simple and quite useful. Let me go to the linear section, and as you can see we have other options here. We can assign a horizontal constraint and also a vertical constraint. I won't go through them because it's the same process as the linear constraint. Let me show you the aligned option. If I assign it here, as you can see we have a dimension constraint, an aligned dimensional constraint. If I change the dimension, you can see that the line will also follow. Okay, I deleted it by accident. Let me assign it again. and that's good. Let me make some geometrical constraints just to show you how the whole drawing will behave as one. Let me assign these constraints to all the lines. Okay. Additionally, let's assign the same center of the radius in the circle, and let me make these two lines as parallel. Okay, I think it's enough. Let me show you this option so we can assign even dimensional constraints to a radius. Let's see how this works. If I assign a radius here, let's say change it to 10, you can see that the radius was changed and applied of 10. We can also do it with a diameter. Let's change the diameter of this circle here. Let's make it 10 also, and you can see that the line will follow the dimension. We can even add an angular constraint, and if you change the angle, the angle of the drawing will be modified. Okay, you see the changes, and let me delete this. And the other option is to convert. So let's say we have ordinary dimensions. Let me apply some just to show you. This is an ordinary dimension. I can convert that dimension into a constraint. So if I change the dimension size in here, you can see that, okay, this was a mistake. I was trying to type 50. Okay, 50, and you can see that the drawing was modified. And I think with that we covered all of the dimensional constraints. They can be quite powerful and come quite in handy. Additionally, we have this view section here. We can make all of the constraints to be hidden. So if I select some of the lines, you can see that the dimensional constraints appear. I can turn them back, show all, so you can see all of the dimensions come back. I can even select what to hide, what to show, so if things get messy, try some of these tools. Okay, with this option here, I can delete the constraints. As you can see, if I click, if I use this option, some of the constraints will be deleted. The parameters manager, this is one of the most powerful tools while dealing with dimensional constraints. So you can see that this menu here appears, and here we have all of the dimensional constraints. We can change the dimensional constraints from here, and you can see the changes will apply to our drawing. So let me say I want to make this D1 line to 60. You can see that the change applied. The changes apply. Let me turn it back. And I think you'll get the basic idea. And I want to talk about this tool here to create a new user parameter. This can be quite powerful if we know how to use it. So we can create a parameter. Let's call it bolt. And basically let's imagine that the drawing in the diameter we have to put a bolt and define that bolt as, let's say, 10, the size of the bolt to be 10, and we can make the diameter to change so that the bolt can fit, so we can use this parameter to change the data of our constraints. So let's make bolt plus 3, and yes, as you can see, the diameter was modified. We can also make the constraints to be dependent of each other. Let's try it. To modify D2 as D1 times let's say 1.5, and as you can see, the dimension was modified. I don't like this dimension. Let's go back, and Actually, there are other possibilities. We can even make the diameter and the radius dependent on each other. Let's say the radius will be the diameter 1 times 2 minus 5. So we can add many functions here, not just multiplications. We can add even complex functions. So it depends on our needs. And basically, this can come quite in handy. These parameters are often used while defining dynamic blocks, so you will see in the dynamic blocks section that these things are quite powerful. And basically that's it about dimensional constraints. You see the main idea behind them, and okay, see you in the next lecture. Okay guys, in this section of the course we are going to talk about dynamic blocks. We are going to cover many use cases. Firstly, we are going to start pretty simple, and I am going to show you how to create an ordinary dynamic block, how to manage it and adapt it to variable situations, just to get the basic idea behind dynamic blocks and how they work. Then we are going to continue, and I am going to show you how to create a dynamic block that can adapt to variable drawing positions, dynamic blocks that can change into a variety of different predefined blocks, dynamic blocks that have array features, and in the end, dynamic blocks that can change and adapt dimensions while using the properties table. So, see you guys in the lectures. Okay guys, in this lecture I'm going to talk about dynamic blocks, and I'm going to go step by step and show you how to create your own dynamic blocks, so you will get the idea why and how we use dynamic blocks. And basically we are going to start by creating an ordinary block and show you how we can modify it to a dynamic block. I'm going to use this to create a block, and the name of the block will be sync. Let me specify a base point, select all the objects, okay, and I'm going to convert the current drawing into a block and allow the exploding option. Additionally, please check this option so we can go directly to the block editor. Okay, and this is the block editor. So when we deal with dynamic blocks, we use these options here. And I'm going to start to explain this section. So basically, if we want to create some dynamic action, we firstly need to assign a parameter. As you can see, we have lots of options here. Firstly, I'm going to assign a base point just to show you, and this will be the point that the block will be inserted. Now I'm going to use this linear parameter and assign it to our block. As you can see, our parameter is assigned. Now we can assign an action to that parameter, and basically that's how dynamic blocks work. I'm going to assign this stretch option. Firstly, select the parameter. Now I have to specify one of the points. I will use this one and specify the frame. So this frame will, let's say, tell the block what section to stretch. And now I have to select all the objects that I want to stretch. Please be careful and select the parameter. Don't leave it out, so you need the parameter so this can work. Okay, these are all 4 objects and the dynamic characteristic was added. Now we can go to this section here and test the block. If I click on it, you will see that a new drawing will be opened where we can try our functionality of the block. As you can see, we have this arrow here. If I click on it, it allows me to stretch the block. Let me show you. And as you can see, our block has this functionality. We can stretch it in one of the directions. Okay, now I'm going to tell you how we can assign the same function and stretch the object in another dimension. So let's close this block editor and let me use the stretch action again. Select the parameter. Now I have to specify another point. As you can see, we can specify the points on the blue dots. If we have an exclamation mark, it tells us that to that point we have no action assigned. Okay, specify the frame and select all the objects. Okay, that's it. And as you can see now, we will be able to stretch the block in the other side. Okay, assign it. So we can use this test block option to test the block, or we can save the block and test it in our original drawing. So I prefer this option and click on it, and now save the changes. Save the changes, and you will see that the dynamic characteristics will be applied. And you can see now we have two arrows and we can stretch the object in both directions. And as you can see, we can try different things out. Okay, what happened? So if I go to the other side, my block will be kind of modified, and I don't want that, so this is basically a good position. We can add even different modifications. I will show you how to do them. And let me go back to the block editor and select the parameter and go to properties. Scroll down, and under the misc section you can see we can change some option. Let's say change the base location, not to start point, to midpoint, and it will allow the block to stretch symmetrically. You can see that the point in the middle always stays in the middle, and we can stretch it in both directions. And basically that's how we deal with dynamic blocks. We first assign a parameter that will allow, let's say, some sort of movement, and assign an appropriate action to that parameter, and the dynamic characteristics will be added. Then if we want to, let's say, change some movements of the block, we can go to the properties section and modify the behavior of the block according to our needs. I want to show you one additional way to modify the block. So let me go back to the block editor, and under the properties section of this parameter, if I scroll down, we have this value set section, and here we can define default dimensions that we want our block to stretch to. We can set an increment option and a list option. I'm going to show you first the increment option, then I'm going to talk about the list option. If I select increment, you will see that I can specify an increment dimension, so the block will change according to that increment, and we can specify the minimum and maximum dimension. Let me just measure the block so I know how to set my minimum minimal dimension. It's around 43, so I will select the minimum as 43, and as a maximum I will select, let's say, 80. I think it's enough. And let me show you what we have now. You can see if I go to the stretch option, I have limited stretching options to the defined increment options. So you can see I am allowed to go between 43 and 80. This can come quite in handy if we have, let's say, some standard drawings and standard dimensions of those drawings. We can use this option and to limit the stretching options, and this limit is assigned according to our needs. Okay. Additionally, I want to show you the list option. This is kind of a more strict option. So in this section, Let me change it and you will see. If I go to the list option, I can define my own dimensions that I want my block to stretch to or be modified to. So I'm going to leave 43.3 as a default one and add some additional dimensions. 70 and 80 I think it's enough, and let me show you what we have. If I save the changes, you can see actually we are allowed to modify the block uh, limited to the dimensions that we set in the list option. So this can be quite powerful, especially if we have standard dimensions for our drawings, and let's say they are not incrementally increasing, so we can define the correct parameters step by step. And you can see, okay, let me show you how we can add let's say a lookup option, and this can be quite practical. Let me go first to the parameters and add the lookup, and you can see there is an explanation mark. I have to assign an action, and this is the lookup action. If I click on it, so this is the lookup menu, and let me go step by step. It will let's say show a list that will allow me to select the correct dimensions I want. First I can change the name. We don't need to do that, but it depends on your work style. We can, in this section, all of the parameters will appear. In our drawing we have just this distance one, so I will select it, and you will see I'm allowed to add the, let's say, lookup options according to this parameter. On the left side we have the input properties, and on the right side we have the lookup properties. So on the left we will define the input, on the right we will define what we will see in the lookup option. So I'm going to go step by step and define the same properties for the input and the lookup. Okay, 80, and I think we are done. Let's say okay, and if I make the changes, you will see we will have one additional option, and that's this arrow here. If I click on it, you can see I'm allowed to change the dimensions of my block. Let's say this is a more organized way to modify your blocks, so you know what dimensions you're choosing from. I prefer this option, and I usually do my dynamic blocks with this lookup option. I find it quite practical. We are even allowed to modify it with the previous option. We can change that and make it possible to be modified just with the lookup option, but for now I think it's good. Basically, that's all for this lecture. I think you'll get the idea. In the next lecture we are going to talk about different modifications. So see you then. Okay guys, in this lecture I'm going to show you how to make a dynamic block that can adapt to variable position. Let's say we have a room with an angle like this in the picture, and we want our block to adapt to that position. So I'm going to show you how we can make our block rotate, align to a position, and even make it flip. This will be our block. I have a separate drawing made here, and as you can see the block is not yet created. So let me go ahead and create our block. I'm gonna name it rotation. Let's select the pick point, select the object, and allow the exploding option. Click directly to go to the block editor, and okay, let me redefine it because we have it previously made. So let's start with the rotation, and under parameters you can see these two rotation, so I can add a parameter that can allow rotation. First I need to specify the base point, so I will specify this point, and the second option is to specify the point of rotation, so this will be our point of rotation. Let me define the angle of rotation and set it like this. Now as you can see, this will be the point of rotation. If I click on it, I will be allowed to rotate the block around the base point. We have to define the action. Here we have this rotate action, so let me assign it to the parameter. Just click on it, select the object, and the rotation is applied. So let's see what we've done. Save the changes, and this is our new block. As you can see, we have the base point and the rotational point. If I click on the rotational point, it will allow me to rotate the block around the base point, and this can be quite useful. So if I want to adapt this block to, let's say, positions like this room here, I will be able to do it. I want to talk about one additional tool that we can use for these positions here, and it's kind of more appropriate. It will allow us directly to align the position, and let me go to the block editor and show you this tool. Under parameters, we can use this alignment position, and this tool is quite powerful, so let me click on it. I first need to specify the base point. Next is the direction of alignment. So actually this will be the direction of alignment, because the line that we want to align to will be in this direction. Let me specify it, and you can see this arrow here will appear. Always make sure that the arrow will point to the position you want to align. And basically we are done. Let's make the changes and see how our block will behave. As you can see, here is the alignment point, so if I click on the alignment point and drag it to appropriate position, you will see that automatically the block will adapt. We can try it on variable positions, and the same rule applies. If we want the other side, we have to approach the line from that side, and the block automatically will be modified. Additionally, I like to show you one additional tool, and that's the flip option. So it will allow us to flip this handle here from one side to the other side, and maybe it's not the most appropriate block for that, because we won't change it much, but it's an example and you can use it on every block you like. So let's go to the block editor and see that option. Under parameters, we have this flip tool. So let me select it and apply the base point. I won't apply it in the same base point because things can get messy. I will go slightly higher, just so I don't mess things up. So I have to define a line of let's say reflection. This is a good line. I will select it and specify the label. And basically this arrow here will appear, and when we click on this arrow, the block will flip from one side to the other side. You see now why I didn't put the base point in the same base point as the alignment option. Okay, so let me show you how to assign an action for this parameter here. And for that, I will have to go to the action section and select this flip action. First, I need to select the parameter, then select all the objects, Okay, select them and everything is set. Let's save the changes and see what we have. As you can see, we have this arrow here. If I click on it, this handle will come to the other side and you can see how the block adapts. So let me delete this and apply our newly created block. And basically that's it for this lecture. Hope you like it. See you in the next lecture. Okay guys, in this lecture I'm going to show you how to make a dynamic block that offers a variety of different predefined blocks. And as an example, in this project we have 4 different drawings and each of those drawings represent a screw with different characteristics that can be used in a specific situation. As you can notice, I already defined the drawings as blocks and we are going to use those blocks to create one block that contains all of the different screw blocks. So let's go ahead and create our block. I will name the block as screws. I won't select any objects in this situation, neither a base point. I will directly go to the block editor. Let's click OK. It requires me to select objects, but I will skip this and go to continue. And now we are in the block editor. For this type of blocks we are going to use this visibility section here. As you can see, in the moment the visibility option is not available. We have to define a visibility parameter, so these options will appear. But first let me insert one of the blocks just to know where to put the visibility option. And I'm going to assign the base position of 0, 0. This will be our first block, and now let me assign the visibility parameter. And as I assign it, you will see the changes will appear here. So as you can see, I have the visibility parameter and the tools are now available. This option, when I click on this option, I will have options to choose different types of blocks, but first I have to define all of the blocks. The first block I think was called, let's say, hex screw. I don't remember it. Let's assign names like 1, 2, 3, and later I will change them one by one. Okay, one additional, and okay, so this will be visibility states. So when I'm in the first one, I will like this hex cap screw to be available. So let's change the name, hex cap screw, and this will be the first option in our visibility block. The second option, I have to define another block, so I will make this block as invisible. Use these two here, and this block will be as invisible. And now if I go back, you can see that in this visibility state I have the block. So let's insert the second block, this Philip flathead screw. Select it, select the position, and add the name to the visibility states, Phillips flathead screw. Okay, and now we have the second block. Let's define the third one, make this block invisible, and assign the appropriate block. So it will be this rounded flathead screw. Let's change the name in visibility states, rename, and spotted flathead screw. Okay, and this is the last one. Make this invisible. Again, insert the last block, socket cap screw, select the position, and change the name. Socket, flathead, screw. Okay, and now we have all of the blocks, and actually we defined uh, all of the visibility states. As you can see, just for checking, I will hover over all of them, and let's make the changes and see what we have. Okay, I guess the block was automatically inserted, but let me show you again. I will insert it once again, and this is our new block called screws. I will insert it here, and if I click on it, we have this arrow here, and from here we can change the block. So we have all of the screws here. If I go one by one, you will see all the options that we defined. And basically you can see the power of these types of blocks. With one block you cover, let's say in this case we cover 4 blocks, we can go even further. One thing is that you can specify this block in the tuple, and by creating one block in the tuple, by automatically you will have multiple blocks. You can go even further, create as many blocks as you want. I don't know the limitation, but I think you can create as much as possible. Okay, I don't know why this visibility state stays here. Let me try and modify it because we don't need that. Edit block section and visibility states. Okay, I'm not allowed to delete it. I guess because let me try something. Okay, I want to show you one additional thing. While we're here, let's make this socket flathead screw as our first choice. So I will bring it to the top. Let's change the name and see what happens. Okay, I'm not allowed because we have the same name. Okay, we'll delete this and make this hex screw. And now you can see our first choice is socket flathead screw. We have all the other ones, and the visibility state is removed. Okay, let's see what we have here, and as you can see, we modified the block as we want. That's it for this lecture, guys. I hope I see you in the next one. Okay guys, before we start, if you like this course and like me to continue and do more videos, please write a simple review and encourage my work. I will really appreciate it and it will mean a lot to me. Thank you. Okay guys, in this lecture I'm going to show you how to make an array as a dynamic block. So whenever you insert the block, a possibility to stretch the array will appear and specify it to the required needs. So in this drawing we have a classroom that has to contain a table and a chair for all the students, and we only have one table and one chair, so let's make blocks of them and assign an array as a property. Firstly, we have to create the block. Let's say I'm going to start with a table, pick up a base point, select the object. Okay, and I can make both of them as one, so things will be quite easy. Select them, convert them to a block, allow exploding, and let's go directly to the block editor. In the block editor, we firstly need to define the parameters, so I will go in the parameter section, and we can use these two here. With these two, we can assign parameters both in the X and the Y direction. So this will allow us to assign an action in both directions, and we will be able to stretch the array in both of the directions. When you send the parameters, please keep in mind to add small distances, because at first when we insert a block, we want a small array, let's say of 1 by 1. If we go and insert large distances, we will insert a bigger array, so keep that in mind. I recommend to assign a small distance, let's say somewhere about here, so I will use these distances, and as you can see, the parameter is added. Now we have to assign an action and define the characteristics of the block. We will use this array option, and firstly I have to select the parameters, then select the objects. Okay, and now I have to enter the distances between the rows. As a base point I will pick this point, and as you can see, all the corners of this rectangle will represent future array of the table here. So I will assign some distances of, let's say, 100 in the x direction and the same distance in the y direction. I think it's enough, and actually we defined our block. So let's close the block editor and apply the changes and see what we have. So this is our block. If I click on it, you can see the parameter points that we defined. So this will be as a base point to stretch the block. As you can see, they allow me to do that. I don't know why, probably the y direction is too small. As you can see, if I stretch the y direction, the other block will appear and the array actually is stretching. We can go even further and stretch the block, let's say to fill the whole room here. We can go in the y direction and make additional changes, and basically that's the idea behind dynamic block arrays. And if I try to insert the block, you can see that the array is actually 1 by 1, and if I insert it, there will be the possibilities for stretching the block. Additionally, I wanted to show you, as you can see on this block here, the insert point is behind the desk. So if I want to insert the block, let's say in the corner, the block actually applies kind of weird, so I have to insert it like this, then select the move option and move the block. And I'm going to show you a little trick that will allow us to add additional point for the insertion of the block. This trick comes quite in handy and is quite powerful. So let me go to the block editor and make the changes. I will even delete the array and make the modifications. So I will go to the parameters section, and if I try, let's say, use a base point and assign it to variable positions, if I insert it once, let's say to this location here, I won't be able to insert one additional base point. And as you can see, I have an error here that base point parameter already exists and I'm not able to define one additional parameter. The trick is we can use this point parameter here and change the insertion points while we insert the block. So I will add additional points, let's say here, 1 point here, I will add 1 point here, and these 2 points in the end. And we will be able to insert the block based on these assigned points. As you can see, the explanation mark, so the points require an action, and this is one of the rare cases where we won't assign any action to the parameters, but actually we will have the functionality that the points offer. So okay, let me make the changes and see what we have. And you can see the arrays are actually modified. Okay, let me go ahead, delete this block and try to insert a new block. And as you can see, the base point is the one we specified. If we want to use the additional points that we assigned, we can click on the control button, and as you can see, the base point actually changes to all the points that we assigned. and we need this point here so we can assign it in the angle. And basically this is an example for, let's say, a not so complex drawing. If we have, let's say, more complex drawings and we need to specify different base points, this trick can come quite in handy. It can save a lot of time and it's actually quite of useful. And basically that's it about this lecture. See you in the next one. Okay guys, in this lecture I'm going to show you how to create a dynamic block and assign the block property table. So we will be able to define different dimensions for a standard drawing, and when we insert the block we will be able to choose one of the appropriate dimensions we want. We are going to use this drawing here. This is a steel E-beam, and basically in production this beam comes with different dimensions. So let's say we're gonna define one block and variable parameters for all of its dimensions. We're gonna go with different height of the flanges, different thicknesses, different radiuses between the horizontal and vertical lines. So basically we define additional block sizes that we can use later on. So let me create the block. I'm gonna call it as IP as the name of the beam. Select all the objects. I'm gonna allow the exploding option and go directly to the block editor. Okay, so we are in the block editor right now, and firstly we need to assign constraints, so we will be able to manipulate with the sizes of the block. For that we are going to use dimensional constraints, but let me first assign the geometrical constraints so everything works together. You can see all of these lines should be connected to each other no matter what, and that's why we need the geometrical constraints. So when we change the dimension of the beam, everything will follow and go as smooth as possible. And for that I'm going to show you a little trick that I actually talked about before. We are going to use this auto constraint option and assign all of the geometrical constraints. If I click on it, let me first go to the settings option. We can click either here or type S and enter. And in this menu here you can see we have all the types of constraints. As you can see, in my case all the constraints are applied. This equality by default is not applied, but we will need it so we can make some of the widths and the dimensions to be equal. So please check this in and apply it, and basically we will use every constraint possible. So I'll go to OK and select all the objects, apply, and as you can see we have all the constraints applied. Common practice is to check everything out and see if things are good. So as you can see we have an equal constraint here that's equal with the other side. We have another equal that shows equality with the one that's down. You can see that the radius is connected with the line. Also in the other case the radius is connected with the line. And if I go up, the same thing applies here. So I think everything is good. We have a parallel constraint in the middle, and let me hide them all just so things are not messy for us. And now we have to assign the dimensional constraints. Let me first assign this vertical dimension. Okay, something's wrong. Probably I used the wrong constraint. We should use this vertical constraint, and let me assign it once again. Okay, and I will call this dimension as D, and basically we will define dimensional constraints to all, let's say, all unique dimensions, and automatically the drawing will be modified because we applied geometrical constraints. Let me assign a dimension for the thickness here, and call it as flange thickness. One horizontal constraint here and call it as web thickness, and we need one additional constraint for the angle here, for the radius, sorry, and I'm gonna leave the standard name. So I think we are all good. We have assigned dimensional constraints to all the unique dimensions. Now we have to assign the block property table. Number of grips, 1 is okay, enter, and here we define the block properties. If I click on this option here, you see that I'm able to assign my dimensional constraints as properties for the block table, but I will leave this blank. I will like to add one additional property and show you how we can modify all the dimensions according to that parameter. So let me go to the parameter manager, and here I'm able to assign that parameter. Let me call it as Ipe as the original name of the beam and assign the value of, let's say, 100. And I will make all the dimensions here to be dependent of this parameter. So let's say for the dimension, for the height of the beam, I will give the same number as the parameter. Okay. The flange thickness, I will make it as 0.035 of the height. The flange width will be 0.45 of the height, and the web thickness will be 0.04 of the height. Okay, I forget the times to add the time. As you can see, my drawing is incorrect. If I modify this, everything will go smooth, and additionally I need to add the radius, and I will assign the same dimension as the web thickness. So as you can see, now our drawing is dependent on the Ipe parameter. If I change the Ipe parameter, all of the dimensions will adapt to that parameter, and we can manipulate with the defined parameter to change all of the dimensions. Let me go to the block properties table and assign our properties. So if I go once again in the same menu here, a common practice is to assign them in correct order, so you later on know and check them. I will assign the parameter as the first property, the height of the beam as the second, and now the web thickness. No, actually all are in order, so I will assign them all together. Click OK, and as you can see, we have all the properties of our table. And now if I add a value here, let's say 100, you will see that all the other dimensions will adapt to this number, and you see we have the dimensions defined for the other properties as well. So we can add as many cases of the parameter as we want, and automatically the rest of the dimensions will follow. This is a common practice to do things, and it's quite easy. It will save a lot of time, and you will, let's say, make a block with different dimensions. Okay, 500, I think this is enough. We can select this block property must match a row in the table. So I will select it, and we will be able to select just the defined dimensional properties. And everything is done, our block is created, and let's see what we have. I will close this block editor, save the changes, and here is our block. If I select it, you will see that this arrow will appear here, and if I click on it, you can see all the dimensions that we defined. Let's say I change it to 200, you can see that our block automatically is modified. We can change it to all of the dimensions that we defined and assign different properties every time. So this is not the limit, we can go even further, assign as many dimensions as we want. And additionally, we have this properties table. If I click on it, you can see all of the dimensions. So this is good for checking to see that every dimension matches your needs. You can even make modifications from here, and it's a pretty useful tool. And basically that's it about block property tables. You can see they are very powerful, very useful, and you will use them all the time. In the next lecture I'm going to show you additionally some use cases, and see you then. Okay guys, in this lecture I want to show you some common examples on how we can use block property tables. In this drawing, basically I've inserted some default blocks that you can find in the tool palette setting, and I will go through all of them and show you what's possible. About the tool palette, you can find it in the view section. This is the tool palette, and let's go one by one and show you what we can do. The first block here, you can find it in the architectural section, and this is the one, the fluorescent. And if I click on it and click on the block properties option, you can see we can define the white. If I hover over the white, you can see that for one white I have different options for defining the height of the block. So we are not limited to one property, we can assign multiple properties to be dependent on each other. As you can see, the same applies for different whites. We have possibilities to define different heights. So let me go to the properties table and show you how the block is defined. As you can see, for 3 whites we have 3 different heights options. Okay, let's go to the block editor and see how the block is actually done. Firstly, we can notice that all of the lines are constrained to each other, so the block will function as one. As you can see, additionally there are dimensional constraints that add, let's say, some functionality. If I go to the parameters manager, you can see all the dimensional constraints, and most of them are dependent from the height and the width. There are additional some standard dimensions, but basically that's how things are done. The block property table, you can see it assigned here. If I go to the block properties table, these are the same dimension and they are actually assigned manually. And basically that's it. Let me close it, discard the changes, and let us see the next block. This is our block, and we can find this block under the civil section here. If I scroll down, and this is our block, concrete pipe, and you can see we have possibility to stretch the block in the vertical direction, in the horizontal direction, but that's not what we want to talk about. I want to discuss this property table, and as you can see we have here many dimensions and we can choose one of them to modify the block. If I go to the block editor, you can see the standard case that constraints are assigned to every line, to every dot, also some dimensional constraints, and basically it's the standard case. But if I go to the block property table, you can see that every dimension is actually assigned manually. And that's why I choose this block, because this is a very common use case. Additionally, let me show you the parameters section, and you can see that the dimensional constraints are also manually added, except the D1 value that depends from the whole parameter, but most of them are manually added, and this is a pretty common case, so in most cases you won't be able to find correlation between the dimensions and assign default parameters that every dimension will depend on. This is pretty common if you deal with engineering, manufacturing, architecture, and similar industries. Basically, You will have a table, and the table will have dimensions that do not correlate, and actually for this block here, someone went to the trouble and defined all of its dimensions. The thing is that there is a probability to find similar blocks on the internet, and things can be quite easy for you if you find the block you need. So, if you need something with similar characteristics as this block, go ahead, try, search the internet, you may find the block you need. And actually that's it. Let's discard this block. And let's see our next block. This is our block, the bolt block. And we can find it under the mechanical section. And this is the one, hex socket bolt. I wanted to talk about this block because let me show you first the functionality that everything works correct. You can see if I change the block type, everything goes smoothly. And the thing is that this block is kind of done differently. You can see we don't have here the block property table, and actually a lookup table is defined, and all of the functionality is defined with the basic parameter and action options. So we don't have any constraints here. We have a stretch option to make the block stretch in that direction, and we can scale the top so things will be modified in this section here. And I wanted to show you that we don't always work with constraints, and as you can see everything functions okay. And actually I think personally I think they've done a pretty good job. So you can try, sometimes different tools can give you the same results. And let us see our last block. This is our last block, the parking block, and you can find this block under the civil section here. And this is the one, it's called parking. And let's see what we have. If I go to the menu here, you can see I can choose different parking spaces. So let me select 4, and as you can see manually the block changed into 4 parking spaces. We can select let's say 8, and you can see how the whole block was modified. So let us go to the block editor and see how this block is actually done. As you can see, basically we have the same case. Geometric constraints are assigned, so we have all the lines connected to each other and maintain the same form. Dimensional constraints are assigned to maintain the dimensions of the block, and actually these dimensions are manually set, so they do not depend on anything, and the whole action is assigned with a basic array action. So all the constraints, all the drawings are connected with a array action that allows us to multiply the parkings in the direction we need. And that functionality is added to the block table. If I go to the block table, as you can see, we manipulate with the white. So if I change the white, the array function will be activated and we will have multiple parking spaces. And this is basically a different use case, kind of smart in my opinion, and actually works perfect. So keep these blocks in mind, use them as base points to define your own blocks. So go ahead, try, experiment, and improve this skill, because this is in my opinion it's worth it. And basically that's it about this lecture. See you in the next one. Okay guys, in this lecture I'm going to show you how to use the parameter sets menu, and I'm going to use this old block that we worked previously on, and this is our parameter set. We have lots of options here, but basically they are kind of a combination between the basic parameters and the basic action set. So let's say here we have predefined parameters with defined actions, so we can use. Don't worry, we can use the same things as the parameter and the action set. This is, let's say, a way to do things faster. As you can see, we have all the functionalities that we can assign with the parameter set. So here we have linear move, linear stretch, and basically when we choose the tool, we should look at the arrow signs. So let's say that some will allow more complex functionality. These two, let's say for example, will allow us to move or modify the block in one direction. Where we have an X sign, we are not allowed to modify it. In the other side, we will be allowed to modify the block. And the same things apply for the other tools. Let's say this linear array. These two options will allow us to modify the block in both directions and also the linear stretch. And the same things will apply to the additional tools. I'm not going to go through all of them because basically I covered that in the parameter and action set. And I'm going to choose these two just to show you, to give you a demonstration how actually we deal with these tools. And as you can see, we have an X here and the arrow is here, so we are allowed to modify the block in this direction, while in the other direction the block will stay the same. This is our action. As you can see, we have a predefined action, but actually the action has a small explanation sign. So we have to define the behavior, and for that I right click on this block and go to action selection set and select the new selection set. And now I have to define the characteristics and how the block should be modified. Firstly, I have to define the stretch frame just to show the block what to stretch. Then select the objects, and actually we are done. Let's see what we have. And as you can see, we are allowed to stretch the block in one direction. The functionality is applied, and you can see that we did the same thing as we did with the ordinary parameter and action set. Okay, let's go back to the block editor, and before we start, you can determine what tool to use depending on your work style. So you can use either the basic parameter and option tools or the parameter sets option. Let me go ahead and show you one additional tool. Let me delete this and use this linear stretch pair, so we can allow the block to be stretched in both directions, just to see the differences between this and the previous tool. As you can see, we have two arrows and two actions. If I hover over one action, you can notice that on the parameter we have an X appearing in the color red. So this means that the action is assigned to that parameter and this other action to the other parameter. Additionally, we need to specify how the action will behave. So let me go ahead. Specified, first select the frame, then select all the objects. We additionally have to specify the second action, select the objects, and now we are done. Let me close the block editor and see what we have. And you can see that we can modify the block in both directions. And actually, we did the same thing as we did with the previous parameter and action options. So basically, this is one additional way that you can use to define dynamic blocks. I usually prefer the basic ones, but it mostly depends on your style. You can choose whatever you want and whatever makes your work more efficient. And actually that's it for this lecture. See you in the next one. Okay guys, in this section of the course we are going to talk about external references, or in short XREFs. Firstly, I'm going to start with a brief explanation on external references just to show you why we use XREFs and cover the main idea behind them. Then we are going to continue and attach external drawings to our project, and I'm going to show you how to manage the external drawings, how to visually inspect them and deal with them in different situations. And in the end, I'm going to show you how to attach PDF and image files as external references. So, see you guys in the lectures. Okay guys, in this lecture we are going to talk about external references, or in short, XREFs. External references in one way allow us to use multiple drawings on the same project and communicate with the data of those drawings. So, one powerful feature is that the project file size doesn't increase with the additional external drawings. So we are able to work on large project and still manage to save some memory. But the most powerful feature is that we can share the data and allow multiple teams to work on different phases of the project, and all that in the same time. For example, one team can work on the architectural design of the project, other team on the structural design, additionally interior design, and so on and so on. All of the teams will work on their own drawings, they will communicate with the data, and in the end combine the drawings to form the whole project. By that, external references can be quite powerful, quite useful if we know how to deal with them. So let me go ahead and show you how to deal with XREFs. Firstly, you need to go to this insert section here and you will find the reference section. All of these tools apply to external references. I'm going to cover them one by one and going to start with this attach tool. So if I click on it, you can see this is a folder that I predefined. So all of our drawings are contained in this folder. And basically a common practice is to save all the external references or drawings in the same folder, so you will know where to reference to. You will see later on that we will need to specify the path to a specific folder, and that's why a good practice is to save them in one folder, a folder you know, a folder you will always reference to. This is my folder. In this example I call it XREFs, and let me select one drawing just to show you what it means to attach it. So this is the section where we deal with attaching XREFs. In the first section we have the name. As you can see, the name of our drawing. If the name doesn't match your drawing, you just browse and find the appropriate drawing for you. Okay, I close it. Let me go ahead and try again. The next section will be the scale section. Here I can specify the scale. The first option is to specify the scale on screen. Additionally, I can specify it as uniform scale and change the coordinate scales. Basically define the scales that are needed for your drawing. I'm going to leave them as 1. And in this section, the previous section, you can, let's say, preview the drawing so you know what drawing you are dealing with. This is my drawing. Insertion point, you specify it on screen, or let's say mine is pre-default, and I know that if I select these 00 coordinates, automatically the drawing will adapt to the situation in my current drawing. So this is good for me. About reference type, we have this attachment option and the overlay option. And basically, these options are kind of similar, but the main difference is when we have overlapping lines. So if I select overlay, the new drawing will overlay the previous drawing. The lines of the new drawing will overlay the previous lines. I don't have that problem, and I am going to go with the attach option, but just to know, you have this overlay option too. The next section is the path type section, where we specify the path type and how the program finds the drawings. I will open this here just to show you how actually the path is saved. And in the path type option, if I click on it, you can see we have 3 options: no path, relative path, and full path. I will start with the relative path because that's the most common use case. and show you what's the main idea behind it. If I click on it, you can see here we have the save path option, and actually you can see that with this option the drawing looks for external references from the folder that actually the drawing is. So the drawing is in the Xref folder, and you can see the Xref drawing in there. If I go to full path, the program looks for the drawing from the system path, and actually this is not so common to use, because if you try and share the drawing to different users, they won't have the same system path and won't be able to find the drawing. Additionally, there is a possibility to change some of the names of the folders here, and the program won't be able to find the drawing. So I don't recommend this. Additionally, there is a no path option, and there is no path, just the drawing. I recommend relative path, and the next section we have the rotation option, so we can specify rotation, and the block units section. I will leave them as default, and I won't change anything. Just click OK and attach my Xref. And as you can see, our Xref is attached. If I zoom in and click on the Xref, the one with the brown color, you can see that this menu here will appear, and I will talk about that shortly. Just to show you the differences between the main Xref, you can see it's kind of faded, and the original drawing actually is full color. So that's how we notice Xrefs. We can change this fading option in here. I can make it to, let's say, 90%, and almost the Xref is invisible. And we can, let's say, make it as bright as possible, and it will appear as the original drawing. I prefer it at 50% so that I know what I'm dealing with. And before we start, I want to attach one additional Xref just to show you that that's a possibility also. To attach multiple external references, I'm going to attach this exterior architecture. Open the drawing, and everything is preset for this. Just I have to click OK, and the drawing will be attached. As you can see, we have one additional external reference. If I click on it, the same menu appears. So let me talk about it. The first section is the edit section, and we have two options: edit reference in place or open the reference. Let me click on the first two just to show you what's the difference. If I click on it, this menu here will appear. I will leave it as default, click OK, and as you can see, the color changed, and actually the reference is the main drawing in this view. So I'm able to make modifications to the Xref from the current drawing. I'm going to make a small modification just to show you. I'm going to make an X here, just to show you that the changes will apply. So that's okay. Now in these two here on the right, we can discard the changes or save the changes. I will click on save changes, and our reference edit will be saved. Okay, and as you can see, we have the X here. The other option is to open the reference in a different drawing and make the modifications from the reference. This is actually the reference drawing, so we are modifying the original reference drawing. So like the previous, I will make a small modification just to show you that the modifications will be applied in the drawing that we are actually working on. I'm going to make one additional X, let's say on this place here. Okay, this is the X. I'm going to save the drawing and go back to I'm in the layout. Let's go to the model, and as you can see, the modifications are actually not made. So we have to update the changes, and for that I'm going to type this option here. I'm going to type Xref, and as you can see, this menu here will appear. I will talk about this menu in the next lecture, but just to make the updates and show you, you can see that this arrow shows me that actually the drawings needs an update to be reloaded, so the changes can be applied. And I can right click on it and click on reload, and actually this it prompts me that the reference drawing has been recently changed. So if I click yes, you can see that the drawing is kind of modified, and we have to approve the changes before they apply to the drawing. As you can see, the changes are in green. I have to click on this arrow here and the changes will apply to the whole drawing. I will close this menu here, and basically that's it. You can see that's kind of easy, it's very practical, and it's very common used. So in the next lecture we are going to talk about managing XREFs, and I hope I see you there. Okay guys, before we start, if you like this course and like me to continue and do more videos, please write a simple review and encourage my work. I will really appreciate it, and it will mean a lot to me. Thank you. Okay guys, in the previous lecture I showed you how to attach an XREF and make some small modifications. In this lecture I'm going to talk about managing XREFs, visually inspecting them, and dealing in different situations. Firstly, I'm going to go to the same menu that we used in the previous lecture. I can either click on this icon here and the menu will appear. As you can see, we have the same menu as previously. I'm going to close it and additionally type XREF just to show you this option is available too. And here we have all the drawings. The first, the building architecture, is the current drawing and its status is opened. Let me just enlarge this menu. We can additionally see the size, the type of the drawing, the date, and the saved path. And these are the external references and they have a status of loaded. Let's say that's one way to know that we deal with external references. Additionally, in this menu here we can see some additional informations. Actually, I think they are the same. We have the size, the type, the date, and so on and so on. If I click on this preview section, you can see I have a preview of the drawing and know what drawing I'm dealing with. Let me go back. Additionally, let me show you how to attach additional files. We can click on this tool here, and as you can see, it allows me to browse and find my file. There is the option, if I right click on this menu, I have options to attach additional files. As you can see, the first choice is the DWG file. I have options to attach an image, a DWF file, a DGN file, a PDF file, and attach a point cloud and coordination model. So we have all of these options available and use them if they are needed. Let me click on the image just to show you that a different menu will appear that I will talk later. So I'm going to close it. About the other options, the next option is this refresh option that we used in the previous lecture. So when we have some changes in the drawings, we can use this option and reload the drawings. We have the same option. If I right click on the drawing, you can see this reload option. The next option will be the change path option, so I'm able to change the path of the drawings. Additionally, if I right click on one of the XREFs and click on open, you can see that I can open the XREFs as the original drawing and make some modifications, change the drawing, adapt it to variable situations, and then apply the changes in the original drawing. Let me close it, go back. Additionally, on the right click, I'm able to use this compare option. So it allows me to select a file and compare the two XREFs and see the main differences. I will choose this interior design, and you can see all the changes are applied to it, green lines. So you are able to to see the differences between the two drawings, I will click this arrow here and apply the changes. Additionally, we can upload the drawing, and if I click on it, you can see we don't have the XREF in the current drawing. In this file, you can notice this arrow here that actually shows that the drawing is unloaded. If I reload it back, the drawing will come back. The next tool will be this detach tool that actually removes the whole drawing from this file path, and we don't have it as an XREF. I can attach it again, specify it, click OK, and as you can see we have the drawing back. Next will be this bind option. If I click on it, it will allow me to bind this XREF with the original drawing. Let me click on it, OK, and now as you can notice we have two files here, the original one and this interior architecture. The exterior architecture is binded with the original drawing, and actually it is in the same drawing. I will go back if I right click again, and the next option is this XREF type. If you remember, when we attach the XREF we had two options to select attach and overlay, and basically these are the same options, so we can modify it from here. Basically this shows that if you have overlapping lines with the overlay section, the lines will be overlaid and they won't appear twice. With the attach, the lines will be attached on the previously created lines. We can change the path, make it to absolute, remove the path, we can select a new path and find and replace the XREF with a different drawing. So basically I think I covered everything. Those are all of the options. These two can be quite useful, quite powerful, and when you deal with XREF you will use it a lot. Okay, let me make this menu smaller and continue to show you the other options. First is this clip option. If I click on it, firstly I have to specify an XREF. Here it says an object. I will specify this XREF and select the new boundary option. The next thing is to specify a selection option. I will specify the rectangle option and choose the rectangle that I want to view the XREF. As you can see, the drawing actually is modified and I'm able to see the XREF inside the rectangle. Outside of it, I am not able to see it. If I click on it again, you can see I have options to click on this section and modify the view outside the rectangle. Now the view inside the rectangle is actually unavailable for us. Let me go back, change it back. So this is a useful tool to manipulate with the views, and if things get messy we can use this. Additionally, there is an option to modify the rectangle and let's say adapt the views appropriate to our needs. And basically I think this covers the clip option. As you can see, I selected an XREF and now this is the external references menu. I have the same option here, create clipping boundary, even remove it. I will click on remove, and as you can see we don't have the boundary anymore. This is the same option that we used before, so if I click on it the menu will disappear. If I click on it again, the same menu will appear. Okay, that covers most of the features. If I go back to the reference section, we have this underlay layers option. So if we have any underlay layers, we can use it. In this section, in this drawing, I don't have any underlays, so this file doesn't contain any layers, and I am not able to make modifications, so I will close it. We have also this hide frames option, but we don't have any frames, so if you have any frames we can hide them, and we can assign a snap mode to or underlays. By default it's currently 12, but we can make it 1. So if you have that kind of issues, look in this tool. And basically that's it. We have one additional option to edit the reference, so we can edit the references from here. And basically that covers most of the tools. So that's it for this lecture. See you in the next one. Okay guys, in this lecture I'm going to show you how to attach PDF and image files to your drawing. And for that, firstly I need to open the external references menu. I will type xref and open the menu. As you can see now we have only the current drawing, and let me attach a PDF file. This is a PDF file I previously created. Let me open it, and here we have to specify some options. First, we can choose the name. If the name doesn't match our PDF, we can browse and find the appropriate PDF. Then we can specify the pad type. We previously talked about it. I will specify the pad type as relative. Next is the insertion point section. I will select specify on screen. The scale section, so we are able to apply a scale. I will leave it as default, and the rotation option. Let me attach the PDF, and this is how the PDF actually looks. If I go to the menu and click on the PDF file, you can see we have all the details here. Under type it's PDF and so on and so on. If I select our PDF, we have this menu here. So the first section is the adjust section, so we can adjust the section, we can change the contrast, we can even make it fade and make it as pretty as we want. We can display it in monochrome. I don't prefer this option, so I will turn it back. We can even create a clipping boundary. As I showed you before, we select the viewports and we can even change them and manipulate with the views. I will remove the clipping boundary. The next option is to show the underlay or make it hide. I will make it to be shown. We can enable the snap. So if I click on this, I won't be able to snap on the drawing. If I go back and click it again, you can see that I will be allowed to use the snap mode. Let me go back. This is the external references tool, so I'm able to change these options, and the edit layer section. As you know, the PDF file was a previous Autocad drawing, so I'm able to manipulate with the layers. I can make them hide, and as you can see, the changes appear in the drawing, and turn them back on. And basically this tool is quite practical when we want to visually inspect our drawing. I will click OK and continue to show you the other options. This import as an object option. So this is one of the most powerful tools when we deal with PDF. If I click on it, it will allow me to make the PDF as an object. Firstly, as you can see, I have to specify an area. I will specify this in my first corner and select the whole drawing. And here we have options to keep, detach and unload. I will click on the unload option and unload the PDF file. As you can see, the PDF file is unloaded and we have only the current drawing, the original drawing. And as you can see, the drawing is modified and actually the drawing adapts to the PDF file that we used. And now our drawing has all the lines, all the objects, all the blocks that were predefined, and this tool can be quite useful when we want to use, let's say, old PDF files, when we want to make changes to a PDF file, and so on and so on. So this is quite practical. It may come to a chance that you will use it, and keep this in mind so you know how to handle it. Next, I'm going to show you how to attach an image, and for that I'm going to open this new drawing and I will attach an image from the external references menu. I will choose this attach image option and choose the appropriate image. This will be mine image, and as you can see, this menu here will appear. The first is the name section. We can browse it for a different name and choose the appropriate file. We can specify the pad type. I will leave it to relative pad. We can specify the insertion point. I will leave it to specify on screen. We can change the scale. I will uncheck the specify on screen and scale the image by my own, and even we can add a rotation. I will leave it as default and attach the image. Okay, it's kind of slow. Let me scale it a little bit. Let's say 10 times, and this is our image. If I click on it, you can see that here we have the image as an XREF, and if I click on it, you can see that the menu here will appear. The first is the adjust section. We can adjust the brightness, the contrast, and the fade. We can create a clipping body. I showed you how to work with this before, and show the image and turn it back on. Background transparency. For this you need a transparent image, and mostly PNG files are transparent, so when you click on this the drawing will be transparent. And basically that's it. You get the idea. It's kind of easy and very useful, I must say. Let me insert the image in this drawing just to show you that that's possible. Image, I will specify the scale on the screen, and let's attach our image. Okay, this is our image. I will make the background as transparent and move it here, and let me remove this frame here. I don't like it, and I talked about this before. We can use this frame vary option and hide the frame. Okay, it didn't work. Let me try again. Select it and hide frames, and as you can see, the frame disappeared. Basically that's it, guys. XREFs in general can be quite practical. Use them and make your drawing. Okay guys, in this section of the course we are going to talk about templates. Firstly, I'm going to start with a brief explanation on templates just to show you why we use templates and cover the main idea behind them. Then I'm going to continue and show you how to create your own drawing template, how to manage it, and show you some common practices. After that, I'm going to show you how to make modifications and update your predefined templates. And in the end, I'm going to show you how to create plotting templates, how to use them, and modify them according to your needs. So, see you guys in the lectures. Okay guys, in this lecture we are going to talk about templates. I'm going to show you how to create your own template and use it later on. I'm going to start with a brief explanation and show you why templates are so commonly used, and I think you will get the basic idea behind templates. A basic example is a company that likes to produce standard drawings with the same dimensional styles, same text styles, same plotting styles, basically uniformly drawings for every user of Autocad. And basically that's where the power of templates comes. If the company creates their own template and defines all of these styles, every user of the company will have the same, let's say, working environment and will be able to produce the same type and quality of drawings. And you can see I've opened this drawing here just to show you this is actually my template, so I call it my style. And you can see that this drawing here has this DWT format, so basically when you deal with template you will deal with this type of format. And now let me show you a possibility how we can manage the template. So I just right click on the drawing and go to the options. And under the file section, if I scroll down to this template settings option, let me open it. And here you can see this drawing template file location and the sheet set template file location. And basically, if I open it, you can see this is my directory. So this is the directory I deal with templates. If I go to browse it, actually it doesn't work like that. Please select the file location that you will be familiar with. You will know how to find it and best suits your work style. I like this file directory and all my templates are saved in this directory, so when I deal with templates I go to this file location and choose the template I want. The same goes for the sheet set template file location. I usually use the same locations. You can specify different ones if you prefer to work that way. Under the default template file name and the default template for sheet creation and page setup overrides, you define the default templates to be opened. So under this section you can see basically the same file directory as the one you specify the templates to be saved, and you can see this DWT file that actually is my template. If I browse it, you can see here I have all my templates. Basically, most of them are the default AutoCAD ones. This is the one by default. Actually, when you start AutoCAD, this template opens. Here is mine, so when I start my AutoCAD, this template is actually the default, and I'm going to show you how to create your own template so we can apply to this section here. So let me go apply and OK. And now let me open a new drawing just to show you. If I click on here new, you can see I have all the templates here. If I choose this, the default one, you can see it's kind of different. Let me open just additionally one. This is my style, and you can see this has no grid. Actually, these menu sections are different. We have a predefined layer. If I go to the Annotate section in here, you can see that I have pre-made text styles. Additionally, I have dimensional styles, and I'm able to use this in my drawings. And in this section, you can see things are kind of different. So let me go ahead and try to create a template from this new drawing based on the default AutoCAD template. If I want to modify, firstly, I can modify, let's say, the drawing style. I can turn the grid off. I can change the snap. I can additionally, let's say, click on some of these options, and when I open AutoCAD, these options will be turned on. We can additionally change the scale. Let's make it as architectural, and we can change even the units. So we can change them from here, and additionally we can type units, and this menu here will show. So we can modify this section here, and we can change the insertion scale, let's say 2 centimeters, and the insertion scale will be always 2 centimeters. We can change the length of the units to, let's say, 2 digits, and the angle type, as you can see, we have radians, grads, and other options. I will use the default one, and there is an option even to mess with the whitening. I usually don't use this, but if you want, you can change that also. So let me click OK. And additionally, in this customization section, we can add additional tools. Let's say if you work with dynamic inputs, you can add them, 3D object snaps, and all of these options will be available for you in this section. So make your drawing style according to your needs, according to your preferences, according to your working style. I will leave it for now like this, and let's show you what else we can modify. We can change the text style, as I showed you, the dimensional style, the letters, the tables, and all these options in this Annotate section. For example, let me change the text style. As you can see, we have these standard text styles, annotative and standard, and the common practice is not to mess with these standards, because different users will have different standards and things can get messy for you. So if you want things to be different, just create a new style and modify that style according to your needs. I usually make multiple text styles. For this purpose, I will create just one, just to show you how it's done. As you can see, we can change the font. Let me make it to Calibri. We can change the size. Let's say we can add annotative features. If you know how to work with them, they can be pretty powerful. I usually prefer them, and I will leave that as on. We can change the text height. I will leave it to 0 because I prefer that. We can add some effects here and change the width factor and so on and so on. And basically, when I use my text styles, I make, let's say, a list. So let's say I have a text for dimensions, text for headings, standard text. Some of my text is with annotated features, some of my text is pre-scale. I prefer the annotated features, but in some use cases I use standard scale. And as you can see, my style is already set. If you want to set it, you just select it and set it to current, and you will be able to use it. About the dimensional styles, as you can see, we have the same standard ones. If you want things differently, the same thing applies here. Just create your new dimensional style and make the modifications. Just click on new. I'm going to call it my style and continue. As you can see, we have lots of options here. I'm going to start with the lines. I'm not going to go through all of them, but you can see we can change the color, the line type, the line weight. We can mess with the extensions, the offset from the origin, and so on and so on. About the symbols, you can change the arrowhead, the arrow size, the break size. We can change with these dimensions here, and I won't mess with them also. About the text, you can see we can change the text style, and here you can select one of your predefined text styles. So as I told you before, create a dimensional text style and use it in this section here. Additionally, you can change the color, the text height, the placement. I will make it as above, and I prefer the ISO standard of the alignment. In the fixed section, we have lots of options. I will go to the scale for future dimensions, and you can make it as annotative. You can even scale it. I prefer the annotative feature, so I will leave it as annotative. In the primary units, you can select the units, the precision. I will make it to 2 digits, and we can change even the other options. Also, there is a section for alternate units and tolerances, and go check them out and make your dimensions according to your needs. Let me just show you this. If I select the same name, we can make some changes for, let's say, a group of dimensions. Let's choose the radius one, and you can see the radiuses actually have the same style that we created, but we can make some modifications that apply just for the radius dimensions. Just to show you, I will mess with the text and I will specify the placement to be centered, and as you can see, the modifications are made. And if I save these changes under the same dimensional styles, the radius will have different text placement. As you can see, in this section under my style, we have the radius section with different modifications. And we can go even further, make modifications to other groups of dimensions, and you can find all the options in here. Basically, that's it. You create the style you prefer and use it in your drawings. Okay, let me close this, and I will go to the letter section just to show you how can we modify this section. I'm going to create a new style and call it my style also. And as you can see, we have a letter format here, so we can specify the format. Let me change the arrowhead symbol just to show you. Okay, let me leave it to box. We can change the letter structure, add some features that are available here. We can add annotative scale or select our own scale, and the context section, we can make it as a block. As you can see here, we have lots of options, so you can modify it and make it according to your needs. I prefer to text type, but mostly depends on your choice. We can additionally change the angle, the style, the color, and so on and so on. Okay, basically that's it. Additionally, we can make modifications to the layers and add the layers that we prefer to our drawings, but I will leave that for the next lecture and show you how to modify the template. Now I'm going to show you how to save this drawing and use it as a template later for future drawings. So I will go to File section here and Save As. Firstly, I'm going to change the files of type and define it as DWT, and you will see directly it will go to the template folder I defined. As you can see, here is the template folder, and here we have all the Autocad templates, the ones that are default and the ones I previously created. Now I'm going to add our new template, and I'm going to call it as my style, and I'm going to add an underscore and new. Let's save it, and here we can add a description, change the measurements and the new layer notifications. I won't mess with them and I will leave them as default. So now, as you can see, we have defined our template. I'm going to show you how to make it as the default one. So go back to options, under files, search the template settings and default template file name. So select it and browse the file that we created. This is our file. I'm going to select it and open, apply the changes, and now when I try to open a new drawing, automatically the new drawing will be according to that template. So let me click here, new, and you can see we don't have the grid. If I go to the Annotates section, here you can see the text style we created, additionally the dimension styles that we created, and under the menu here you can check the scale and see all the modifications that we made. And basically that's it. You can see how practical this can be, how easy it is to be modified, and please use it if you need to. So see you in the next lecture. Okay guys, in this lecture I'm going to show you how to update your template and make some modifications. But before we start, I wanted to talk about this menu here, and basically this is a menu. When we start AutoCAD, it automatically goes to this menu, as you can see the start option here, and we can choose our templates from here. If I click to this open files option, you can see I'm in my template folder and I am able to choose the appropriate tempo for my need. If I click on open a sheet set, you can see I'm in my sheet set folder and I'm able to select the sheets I need. And there is this option, get more templates online. So if I click on this option, it automatically directs me to the Autodesk site where I can find some predefined templates. I can encourage you to go try, maybe you will find some suitable templates for your needs here. Additionally, there is a possibility you can type AutoCAD templates and some other sites will appear that, let's say, have predefined templates. And basically I think that covers the whole menu here. So if I go to this start drawing, automatically my default template will open, and under the section here templates I am able to choose the appropriate template. Also by default is my style underscore new, the one that we set before, and that's my default. So let me go. As you can see, I'm in the template that we previously created. You can notice that from the line scale, from the grid, and basically those are some of the indicators. So let me try and show you how we can modify it. I'm going to do that with the layer property. So I will define predefined layers to my template, and we can do that in two ways. The first way is to change our original file, this DWT file, and make the modifications and then save it later to the same folder. Additionally, we can open a new default drawing with the same template, make the modification and save the file as the predefined template. So basically those are the same approaches. Now let me make some new layers in this new file. I'm not going to go through details, but I'm going to show you how to, let's say, create your own layers. I'm going to create my main layer, change the color and add an appropriate wine weight. So this is my main layer. As you can see, we have other options here, but when I create my layers, I usually change the color and the wine weight. In rare cases, I mess with the other options, but there is the possibility to do so. So as you can see here, you can make the layer freeze, turn it on, off, lock the layer, allow the plotting. We can change the line type. So here you can see we have different line types that we can choose from. We can make it dash dot, dashed, and so on. So here we have lots of options. I will make it as a whole line. We can change the transparency, even this new VP freeze option, and we can add a description. I will create additional layers. Let's say this will be my secondary layer. I will change the color and the line weight, and one additional layer, let's say for dimensions. So I will call this, let's rename it, and I will call this as dimensions, and change the color. Yellow is a good color, and the line weight to a smaller one. And I will set my main layer as the default one. Let me close the layers, and as you can see we have all the layers here. If I go to the templates file, you can see the template file has no layers. So let me make these changes and apply them to our template. So I have to save this file as my template. Let me select the DWT format. So directly the program will go to the template folder. Here are all my templates, and this is our current template. Let me save it. Okay, I'm not allowed because the template is already opened. Let me close it and again try to save this folder, this file, DWT, and this is our file. Let's save it. I won't mess with these options, I will leave them as default, and our new template now will have the layers. As you can see, if I open a new drawing, the layers will be applied. And basically that's it. In the next lecture I'm going to talk about customizing your plotting templates, so see you then. Okay guys, in this lecture I'm going to show you how to create your own plotting templates, how to use them, how to modify them and make them as reliable to your needs as possible. Currently, as you can see, I've opened a new drawing, it's called templates, and basically this drawing is based on the previous template we created. So if I go to the layer section, you can see that we have all the layers that we previously defined. Additionally, you can check with this menu bar here. As you can see, we have the same scale, the grid is off, and basically those are some of the indicators. So the idea is to create the plotting templates based on newly opened drawings. So basically when we deal with plottings, we use this layout section here. This is the first layout, as you can see, is the default one, and basically when you open a new drawing, the default one will look like this. So I'm going to go step by step, show you how to modify this layout, and we are going to start with the page setup manager and show you the options there. Then we are going to continue and I'm going to show you how to add different paper sizes for plotting, add your predefined, let's say, plotting style with different color, different line weights, and so on and so on. and I am going to show you how to insert a predefined title block to your drawing. So let me go to the page setup manager, just right click on the layer and you will see that option, and here we have the two predefined layouts. If I try to modify, you are going to see under the page setup section that the name is actually defined as none, and basically that's not a good choice. So just for a demonstration, if I try to rename this default layout, you will see that actually that's not possible. So basically, when you are in this section, just click on new and define your new layout. Later you can delete the default ones. I'm going to call my layout as my sheet, and I will add the paper size, actually an A3 format as a default. And here you can see the name of the page setup. We can add a printer. Here you can find all the default printers on your computer, and I'm going to use the default DWG to PDF printer, and actually this is a pretty good choice if you don't have any other options. As you can see, here we can select the paper size. These are some default paper sizes that come actually with Autocad. We can additionally create a default paper size, and I'm going to show you how to do it later. About this section, this ISO standard paper sizes are actually good. Under PDF options, here you define the quality of your PDF. So we can merge control, let's say, control how the lines interact with each other in our PDF. We can specify the vector quality, raster image quality, and change this according to the needs. I'm going to leave it as default, and under this properties section here we can define our custom paper size. As you can see, under custom paper size, this is some default I previously created. Start from scratch, here I have to define the paper size. Actually this is a good size for me. We can define the units, and next here we define the margins. I'm going to leave them as 0, and here we can specify the name of our paper. I'm going to call it our new paper. Okay, let's say our paper, and I'm going to leave the paper size and finish, and now we have the newly created paper size. If I go to OK and scroll the paper sizes, on the bottom you can see the newly defined paper. Okay, under plot area we can select what to plot. Here we have some options. I prefer the layout option. This window option is actually when you plot directly from your drawing. Display, but I will leave the layout option. Plot offset, I'm going to leave this option to 0. And here we can specify the scale. The default one is 1. I will leave it to 1. You can choose whatever you want. In this section we define the plot style. So here we have some default plot styles and some I additionally created. As you can see, this is my plot style, and I am going to show you how to create your own. And basically when you want to define your own plot style, you just go to new, and here you can, let's say, start from scratch and define the style according to your preferences. So let me start from scratch, go next, define the name of the style, let's say my style, and I'm going to add an underscore and new. Actually, one additional underscore and new because I previously created the underscore new file. And if I click on this plot style table editor, here we have all the options to modify our plot style. As you can see on the left, we have the plot style section where we can define the color. On the right, we have the properties section where we can choose different options. And additionally, there is a description option to add some description. Under properties, as you can see, we can change the color. I'm going to leave it to black. You can make it to grayscale. You can change the screening, the line type, the line weight, and so on and so on. So you have lots of options here, and make your style according to the style you need. I will leave this as default and go to finish, and as you can see, this is our new style. I will leave it to monochrome for now and show you later where to find your newly created file. So here we have plot options. You can define even the drawing orientation, let's say to portrait, landscape, and even there is an option to plot the drawing upside down. So I'm going to leave it as landscape, and let me show you now where to find your plot style. As you can see, our new layout, and I'm going to set it to current. And actually the changes applied. I'm going to delete this, and this is our new layout. Let me go ahead and show you where to find the plot style. You right click options, and under files, printer support file path and plot style table search path. You can find the directory where the plot styles are stored. If I copy this and paste it here, and here you can see all the predefined plot styles. This my style is my default plot style, and here you can see the newly created plot style. Additionally, the other ones are the default ones. You can see grayscale, monochrome, and so on and so on. Okay, and let me close it. So this is our layout. Let me change the name so we know what we are referring to. I will give the same name as the one in the page setup manager. So let me check the name, and it was my style and the page size. So let me rename it ms and the page size. Okay, now let me delete the other one, and we have our layout. Additionally, we can modify the layout. We can add a title block with borders. So let me give you an example. I won't do the whole title block, but just to show you what I mean. And in this section, you can define let's say the logo of the company, the project type, the dimensional sizes, and so on and so on. As an example, now we are going to import a predefined layout with a block title. Just to show you an example, I'm going to create a new layout and select the option from template. And as you can see, here we have all the Autocad's predefined templates. The last four ones are with a predefined block title. So I'm going to use this one. And in this section, if the template had multiple layouts, all of them will appear in this section. This template has one layout, and I'm going to choose this layout, click OK, and this is our new layout. As you can see, we have a different paper size, we have a title block, and already the layout is predefined and ready to use. I'm going to delete the additional layer, and now our drawing has these two layers, the one with the sizes that we defined and the one with the imported block. Now I'm going to show you how to save this drawing as a template and use the layouts in different drawings. I'm going to select this DWT, and directly it will open the folder of my templates. As you can see here, we have all the templates that we defined and the default ones from Autocad. I'm going to save our template here, and I'm going to call it mystyle_sheet, and I'm going to add one additional underscore in new, save it like this. We can add a description here. I will leave it to default, so click OK, and now our template is created. So if I go ahead and open a new drawing without any layouts, I will be able to import my previously defined layout. So as you can see, in this drawing we don't have the layouts we defined. Actually, we have only this default one. So I'm going to go right click from template, and as you can see, here is our template. If I click on it, you can see the two layouts we created, the one with the block and the one with the size. I'm going to import firstly the one with the paper size, and as you can see, we have that layout. Additionally, let me add the other layout. So select the template, open, and select the right layer. And as you can see, we have that layout also. And basically, that's how we deal with templates. Okay guys, that's it for this lecture. See you in the next one. Okay guys, in this lecture we are going to talk about annotative drawings. I'm going to show you the basic power behind annotative features, go step by step and show you how to make your drawing annotated, and make a comparison between a standard drawing and one that has annotative features. As you can see, we can mess with all these features in the Annotate section. Firstly, we can make our text to be annotated, then we can continue with the dimensions, the letters, and additionally the hatches and even the blocks. So in this drawing here, I will give you an example and show you what's the main difference between annotated drawings and standard drawings. On the left side, I will use the annotative features. On the right side, I will leave the drawing as default. And I'm going to experiment with text styles, dimensional styles, and blocks. Firstly, I'm going to start with the blocks. As you can see, I pre-inserted some blocks, then exploded them just so we can go ahead and do this step by step. Firstly, I'm going to create my standard block and I'm going to call it as basic car. Pick a point, select the objects, and we can leave the rest of the features as default. And this is the annotative feature that we will add in the next block. Okay, redefine, because I previously defined this block, just redefine, and as you can see we have our basic block. Now let us create the annotated block, and I will call it as annotated car. Pick a point, select the objects, and add this annotative feature, and click OK. Now our block is created. Additionally, as you can see, I predefined the dimensions and the text just to show you how to make it by your own. If I click on here, you can see that I have all the text styles, and let me go to manage text styles. Basically, the standard is and these annotative are the standard text styles. So as I showed you before, we usually don't mess with them. If we want things differently, we just create a new text style. And I've created these two, the basic text and the annotative text. Basically, these two have the same features, so the font is the same, the font style, the paper text height, the effects, and the width factor. The basic difference is this option here. You can see under the size section, I have added the annotative feature to the annotative text, and the basic text, this two is not selected. And as you can see on the annotative style, I have this icon here that in one way shows that we have annotated features. If I hover over my text, you can see the same icon or symbol appears. If I go to the basic text, that's not the case. The same thing actually is for the other drawings, as you can see in the blocks, also on the dimensions. And let me go ahead and show you how to manage the dimensions. As you can see here, we have the standards. This is also a standard for me, and this annotative. So if we want things differently, we just create new styles and make them according to our needs. So this is the basic dimension. If I go to modify, we can add the annotated features, and basically I've defined the two dimensional styles the same, so I won't go through every option here. Just under the section fit you can find this annotated feature. As you can see, for the basic dimensions this feature is not selected. If I go to the annotated dimensions again to modify, in the same section you can see that the annotated feature is applied, and basically we can see the same thing with the icon in front of the dimensional style. So basically that's how we define the dimensions. And before we start, just make sure that this show annotation objects is applied, so we can see the changes, and also the add scales to annotative objects. Please add them, so when I try to change the scale, the changes will appear. So let me begin. If you want to change the scale, you can see the drawing will adapt, and basically that's the main idea behind annotative drawings. And you can see the difference. The basic car actually didn't change. If I change the scale again, you can see another change will appear, and the dimensions will adapt to the scale. The thing is that the dimension won't follow the changes in the block, so basically they just change the scale and become bigger, so we can see them in that appropriate scale. So if I go to the layout section, here I've defined two viewpoints, so we can manipulate with the views and add different scales to different views. And let me go ahead, select this view here and apply a change in the scale and change it to this scale. Let me zoom up. Actually the scale will change, but the features of the annotated features will be applied, and as you can see the car is actually bigger than the one with basic features. So in this viewport we can add a different scale appropriate to that viewport, and let me try this scale. Let's zoom out. Okay, it actually didn't work. So basically we have to apply the same scale in the model, so the changes will apply, and actually the change is applied. Okay, let me go back to the layout and try it again. Same scale, and here it is. The drawing actually adapts to the scale. But if I try a different scale that we didn't use in the model, you can see that the annotative drawing even doesn't show up. So I firstly have to change the scale in the model. Let's change it to the same scale, and the changes apply here. So if I go back to the layout, the changes will apply to the layout in the same scale. And as you can see, the changes actually applied, and our drawing has the same scale. And basically that's it. This is a very powerful tool. If used appropriately, it can make your drawings pretty efficient. You will be faster in plotting them and making the layouts. So if these tools, if used appropriately, can't really make a change in your efficiency. So that's it for this lecture. See you in the next one.